there are some nice properties of the rank of a matrix that will be helpful later on. So let's say I have a system, and in this example, it's already written in the augmented matrix form. Now the matrix A, which is going to be the left part here, let's say my matrix A is an m by n matrix, so m is going to be the number of rows of my matrix, and that will correspond to the number of equations that we have. So I'm going to have 6 equations to begin with. Now then, the n here is going to be the number of columns of my matrix A. So in this case, my matrix A has, let's see, 10 columns, so my n is equal to 10. And that means this is also the number of variables that we have. So there are, there are 10 variables in my system. So there are 10 variables. Now then, this matrix is already in the reduced row echelon form. I have a leading one here, 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 and here. So that means I have 4 non-zero rows. So the rank of my matrix is going to be 4. Notice how this number 4 represents the number of equations that matter. So it seems like I only have the first 4 equations that matter, because the bottom 2, if you read it out, this is just 0 equal to 0 and 0 equal to 0. So among the 6 equations that I have to begin with, only 4 matter. And that is what the rank of a matrix means. Only 4 matter. Now, another way that we can view the rank is that, well, we see that the column that has a leading one correspond to the variables that are dependent. So these guys are all dependent variables. So that means the number of dependent variables that we have are going to be 4. So this is x1, x2, x3, and then x7. So among the 10 variables that we have to begin with, I'm going to have 4 that are dependent. So this is the same number as the number of equations that matter then. Now then, well, I have 10 variables and 4 are dependent. So what that means is the rest of them, which is going to be 10 minus 4, which is 6, that's going to be the number of free variables. So among the 10 variables that we have, 4 is dependent and 10 minus 4 is going to be free. So n minus the rank of the matrix is going to be the number of free variables. And we kind of see that here. So this guy, this guy, this guy, this guy, this guy, and this guy. 6 of them are going to be free. And now we can deduce something from what we are looking at here. Remember that m is going to be the number of equations. So m is going to be the number of equations. And then the rank of the matrix is going to be the number of equations that matter. So what that means is the rank of the matrix. The rank of the matrix has to be less than or equal to the value of m. Has to be less than or equal to m, because, well, the number of equations that matters cannot exceed the number of equations that we have. And we also see from the latter half that the rank of a matrix is also the number of dependent variables, and that cannot exceed the number of all variables that we have to begin with. So the value n here, this is the number of variables, while the rank is just the number of dependent variables. So what that means is the rank of a matrix has to be less than or equal to n as well. Rank of a matrix has to be less than or equal to n. Now, if we combine this together, because rank has to be less than or equal to m, rank has to be less than or equal to n, so that means the rank of a matrix has to be less than or equal to the minimum of the two. And we will see later that when the rank of a matrix equal to m, or when it equal to n, then something special is going to happen.